At a facility in central Sweden, historic manufacturing activities resulted in the contamination of the soil and groundwater below the site over time. With TCE concentrations measuring up to 5,000 micrograms per litre and DCE up to 6,000 micrograms per litre, it was determined that remediation was necessary in order to protect the wider environment, especially as the site is located close to a water supply area.
My name is Christine Forsberg and I'm working as a project manager at SGU. Our group at SGU are acting on the behalf of the government, and we are responsible for remediating and investigating contaminated sites that were previously operated by the central government. And we also deal with orphan sites. SGU has several sites that are contaminated with chlorinated solvents. This site was chosen for remediation since it had all the right conditions for serving as a test site. It's relatively small in size, it had moderate levels of contamination, no dig levels are found, and the geology consists of clay and silted sediments. We considered a number of different remediation methods. Thermal, for example, was thought to be too expensive compared to the environmental and healthy risks. In situ chemical oxidation was considered, but as we all know, it's a contact sport, and we found it to be very hard in these clay and silted sediments. Monitored natural attenuation would work. We can see that we have natural attenuation occurring, but it will take a lot of time that we didn't want to wait for.
After a comprehensive review, SGU opted for an enhanced reductive dechlorination approach through the injection of controlled release electron donor substrates.
We have 3 site-specific challenges. It's an active manufacturing site. We have a lot of cables and pipes in the ground, and the fine sediments could make it hard to get a good radius of influence. This is why we are carrying out this project as a 2-step procedure. Step 1 is the pilot trial. Step 2, the full-scale works, which has been designed and planned based on the result from the pilot trial.
Envytech and GEO were the team selected to carry out the remediation works. Envytech and REGENESIS first developed the design of the in situ remediation. Due to the low permeability of the aquifer material, we recommended trialling 2 of our electron donor technologies in a double pilot study.
One of the most important things with carrying out in situ remediation is to carry out a pilot test first to make sure that you verify the data from previous investigations, as well to see that your selected method will work as designed. If it is, then it's fine, you can go on and carry out the procedure as planned, but if not, then you still have the time to readjust for the full-scale implementation. And this makes that you don't waste time, money and resources on what could be an inefficient procedure. And this is one of the great benefits with doing a trial.
So on this site, we trialled 2 appropriately soluble electron donors. We trialled 3DME, a high volume, low viscosity product. It typically comes as a concentrate, and we recommend that you mix it 10:1 with water to form an emulsion, which can then be injected into the subsurface. Once in the subsurface, it ferments and releases hydrogen, which can be utilized as an electron donor in the reductive dechlorination process. We also trialled HRC. HRC again is an electron donor, but it's of a very high viscosity, and we would typically recommend it for sites where the geology has been reported to be of very low permeability, such as here where we have clays.
The pilot tests were carried out by GEO during summer, and after 2 months of monitoring, the results confirmed the preferred technology for the full-scale works.
As the results from the pilot test show that the ground could take both the volumes of HRC as well as the volumes of 3DME, we choose 3DME since it's a high volume product, gets better spreading, and it has a lot lower viscosity, which makes it easier to mix and inject in this type of cold climates. So we are now on site doing the full-scale injection with 3DME.
The lessons learned from the pilot study were used to complete an accurate full-scale design. The full-scale 3DME design comprises a series of injections that can be completed within a single week.
We started yesterday doing the full scale with a spacing on about 4 meters, so it's going very well. We're doing it with the 3 rigs, direct push, and just before we hit the bedrock, we stop. We are starting from the bottom, and just before the bedrock, then we have the moraine going into the moraine, and on the top of the moraine, the silt and clay layer will come, and that's a little more tight, so we have to be very polite while we are injecting in that space. And we can feel that also on the pressure, on the rigs, on the pumps. So it's very good that we lock that, so we know exactly how much pressure we can put in, and so we can follow what we did in the pilot test.
Given Sweden's predominant geology tends to be till or thick marine clays underlain by crystalline bedrock, there have been concerns that enhanced reductive dechlorination, ERD, is difficult to achieve.
It's always interesting to see about clay. We have a lot of clay material in Denmark and also here in Sweden. So can you do this injection work in clay? That's what it's all about. Or do you have to have other techniques or other methods to clean up? In fact, it's not always good to do things like this in clay material, but that's why you have to test it before. But in this case, we can see that it's very good. The pilot test learned us how to do it here, with the right put the right pressure on the pumps, so it will not come up and make daylighting, but it will go into the layers. And we can also see it's different from layer to layer.
ERD using 3D microemulsion has been successfully applied on thousands of sites across the world in varying geologies, including clays and silts. This Swedish remediation project, carried out on behalf of SGU, shows that it is also a worthy remedial option in the Nordic countries, and that the presence of clay and silty sediments in the subsurface in reality is not as challenging or limiting as often perceived. SGU will continue to take groundwater samples to monitor the efficacy of the treatment. Regulatory closure of the site is expected to follow within 3 years post-injection.